the other unit for British unit. We have many units. Pressure, it is have many units. PSI, bar, atmospheric, Pascal, sometimes kilogram force per pound force per feet square. But in the conversion, in the converter in the calculator, you will find bar, atmospheric, PSI, and Pascal. This is the default. Okay, be careful because he play a lot for British unit for that. What's playing for that? He given unit for pressure, regular pressure for British PSI. What's PSI? Pound per square inch. And normally the unit used in the equations is feet. So even if it is British, we need to convert from inch square to feet square. It means we need to convert this unit to pound force per feet square. Be careful for the units, please. Okay, I will see with you for practice problems related for that. Okay. Actually, we have 3 types of devices here. I mentioned here to measure the pressure. But these 3 devices, each one measure something, not the same other. And be careful for the meaning for each one. Some questions coming asking for pressure device, but read carefully to know what is the type for pressure need to measure. First one, barometer. Actually, barometer, it measures atmospheric pressure. Again, barometer, it measures atmospheric pressure. It means only atmospheric? Yes, but we know the atmospheric. No, but if you change the elevation, the altitude, the level, measure on the land, measure on the mountain, measure under sea, and so on, different level. The pressure atmospheric is the same? No, different. So this device used only to measure what? Pressure for atmospheric. This is a shape, if you remember this one. All study for this experiment when he can young, something like this. And we make a balance. It means the pressure here inside applied for the liquid outside the tube is equal to the distance here, the column of the liquid inside. Okay? Okay. This device used to measure the pressure. And the B atmospheric is normally 100 kilopascal, 1 atmospheric, 1 bar, and 1 important unit, which is related actually for this experiment itself, 760 millimeter mercury. You remember this value or not? 760 millimeter mercury.
Yes, sir.
Why mercury? Because the mercury density for this one is heavy, and if I use it to water, the column is very high. Okay, 760 millimeter mercury. Okay. This one. Important thing. One point is is what? It is common for the 3 devices. What is this thing? All these 3 devices measure the pressure as a form of head, as a unit of head. What mean of that? This barometer I draw, it measure distance, not pressure as a unit, not Pascal, but measure height. Measure what? Height. Be careful for this note, please. We mentioned for the pressure with two ways. With pressure of the unit of pressure itself, referred to Pascal or equivalent, or we can mention for or represent this pressure by meter, by unit of head, by unit of what? Unit of head. Okay? So why like this? Because the equation for the pressure itself is equal to rho g h, rho g h. Okay? Anyone please raise your hand if you want any ask questions. B atmospheric is equal rho g h, rho g h. So rho is density, g is constant. It means if I give you h, I can get pressure. It means both is represented the same thing, represent pressure. I can present this one as a pressure form, and I can present this one in head form. All head form is equivalent. Same like pumps. Pumps I can mention for this pump is 2 bar, and sometimes I can mention for this pump is 20 meter head. All the same. Okay. So the common for these three devices is measure the pressure as a head form. 3 is measure a pressure as a head form. First one measure atmospheric. Second one measure is called, firstly is the name for this one is piezometer. Measure what? The vertical tube in which the liquid raises due to the pressure increase above atmospheric pressure. Read carefully please. The pressure increase above atmospheric pressure. It means the piezometer measure what? The pressure increase above atmospheric pressure. It measure what? It measure gauge pressure. It measure gauge pressure. Why? Because it measure pressure increase above atmospheric pressure. But the data for that is atmospheric. So it measure what again also? We know now the type of pressure is gauge, but measure what? Measure pressure at point here. Measure pressure at point. It means this column refer to the pressure at this point. If I change the point here, we found the pressure at this point, and so on. Okay? It means barometer, measure what? Atmospheric. Piezometer, measure what? Pressure at point, and this pressure is gauge pressure. This pressure is gauge pressure. And the third one is, close this. Manometer. Third one is what? Third one is manometer. Manometer. YouTube. As you see here, the shape is YouTube. U. Okay. This measure what? Measure pressure difference between 2 points. Each word very important. Measure pressure difference between 2 points. It means if I talk for any questions, and you don't know what is referred for this question, I talk for in the fire bomb, and I took for something measure 2 difference pressure. What is this device? And one of the choices is manometer. Directly manometer. Okay, clear. Manometer is a device to measure pressure difference. It means this device measure pressure here at B1? No, can't. Measure pressure here at B2? No, can't. But it is measure B2 minus B1 or B1 minus B2. It means the value, it is referred to B1 or B2? No. It is referred to B1 minus B2. I can't know B1 or B2. But how to know that? How to know B1 or B2? You can know B1 if I give you the value for B2, but it is not measured from the manometer itself. The manometer itself, if I connect this leg with this leg, if I connect this leg and this leg to flow, and we have this change, what is the pressure at this point? No, I can't to give you value or give me the difference between these 2 points for measuring. Clear? It means the manometer is measure difference between 2 pressure. Important? Yes, we will see this importance for next slides. Okay, it means P1 minus P2 is equal gamma H. What is gamma H? Actually, it's the same first equation, rho GH. Rho G is gamma. I can write it gamma H, I can write it rho GH, but default using for the equations, gamma H. Okay, so any question? I will open if anyone have a question. Anyone have a question? The tree is clear?
No, it's okay.
Okay. I give you access to solve this with me. Answer, please.
Possess all the above properties.
D. Possess all the above properties.
D.
It is D.
D.
Yeah. Surface tension, compressible, viscous.
Okay, correct. Answer, please.
C.
Okay. Why?
D.
Piezometer. All three devices measure head. Okay. All unmuted now. Anyone you can join. Static fluid.
Only normal stresses can access D.
Yes, correct. So we will take a break.
Can you go back, sir? 1 minute. Question number 10.
No problem, we can go back.
Static fluid. Okay.
Okay.
Yeah.
Okay, take a break, 10 minutes. Okay. We're going to break now, and after that we continue. 10 minutes break. Okay, all ready? Read please carefully first. Finish reading. Okay, for this one, talk about for piston. This piston, area 500 millimeters square. What is the piston mass? Required this mass. Required mass by kilogram. It exerts pressure 50 kilopascal above atmospheric pressure on the gas enclosed in the cylinder, and given G assumption by 9.81. For this type of these problems, require the pressure, require something related for pressure. We will study the body itself. What is the body affected here by forces? This piston itself. So we will study this piston and the free body diagrams, right? Like stress analysis. What is the forces applied here for this piston? Actually, the weight of the piston itself, mg, and the force due to pressure atmospheric from outside atmospheric pressure. We have a force due to this pressure. Also, we have a force coming from the inside piston itself, from here, from inside, because inside here the pressure is 50 kilopascal. So we have a force due to the internal pressure here. Finally, we write the equation for balancing. mg is down plus b naught a is down equal BA going up. This is the equation itself. What is given, what is required, what is not, we don't know the value or something like this. To be clear, the equation is ready to solve. Mass, actually this is the required. G is constant, is given. Area, the same area applied here for both. And we have this area, but be careful for units. So what is remaining now? P and P naught. We have one pressure here, this one. Okay, it means this one referred to this one or this one. No, this one is inside here. So this one is referred for this P, 50. But the question is, we put it 50 or we need to change something? Actually, it depends on this B. What's the meaning of that? This one refers to atmospheric, normal condition, atmospheric condition. Okay, I will. You have a question here. Okay.
Yeah, this equation is for what, sir?
Again, question?
Yeah, no, this equation is for this piston.
This normal balancing. Just we have a body and we need to make balance forces. We make balance for the force in X in Y direction. For what is the force applied up and what is the force applied down should be equivalent to be in equilibrium. Clear? Again, pressure. First, we need to know what is the type for this pressure, 50 kilopascal. Read again. Above atmospheric pressure. It means this which type of pressure? Absolute or gauge? I will make unmute to share with me. But anyone have a disturbance in the environment for him, you can close the mic.
Absolute pressure.
Absolute?
Yeah.
Absolute pressure. This one, again, 50 kilopascal above atmospheric. We talk about here before this absolute. The second datum is atmospheric. He mentioned here 50 kilopascal above atmospheric. It means he measured from
Gauge.
atmospheric.
So it's gauge.
It means this type is
Gauge.
gauge. So if we substitute here for this pressure as a gauge, must be this one represent as gauge also. But if you need to substitute for this pressure as atmospheric, as absolute, should be this substituted as absolute. Okay. We'll check one by one and get the same answer at the end. mg, actually this is the required. We can modify the equation first before we start for. We can make a simplification. This put in other side, and we get m at the end. B node. Sorry. B. This put in other side here minus B node multiply area common factor divided by G. Correct?
Yeah.
I will use at the first case B gauge pressure. So the mass equal to, what is this pressure? 50 kilopascal. 50 kilopascal minus, what is this pressure?
Gauge pressure.
Okay, value.
50.
This referred to the outside one, atmospheric. What is the value for this one? Actually, P node is referred to the atmospheric outside. So it refers to this line itself, correct? What is the value for this line?
0.
Great. Correct. Why 0? You tell me before this value is 100 kilopascal, is 1 bar. Yes, but 100 kilopascal as measured from absolute. But if I want to measure as a gauge, 0, because this is the datum itself for the gauge, correct? So this 50 for the pressure inside, this 0, and we need to multiply to 10 to the power 3. Why 10 to the power 3? To convert unit from kilopascal to pascal. Then multiply to area. What is area? 500 millimeter square. Multiply to what? 10 to the power negative 6. To change it from millimeter square to meter square, because millimeter to meter negative 3, and this is square, it means negative 6. Correct? What is G? 9.81. Clear or not?
Not clear.
I open all again. Actually, I open all, Mr. Muhammad. You can check yourself, please.
Sir, this can you explain 1 second, please?
Okay. First, I make balance for the forces for this piston.
Yes.
Balancing of these forces, what? Force up and force down. So force down, weight, mg, plus the outside forces due to atmospheric pressure, B node times area. And force up, this force due to the internal pressure inside the piston, it means P times A. And we're going to make a simplification for this equation to get the equation for the mass equal B minus B node times area divided by G. Till now, I think clear, yes?
Yes.
Yes, clear.
Plus the step substitution. No
Answer,
problem for
please.
the area, 500 millimeter square, but just only we change the unit to be meter square.
50.
Standard. And no problem for the G, also 9.81.
Sir,
But
this
the problem-
G we can, here we should take 9.81. Or it is said that assume if it is not given, we should take same 32.
Yes, if it's not given, take it the 9.81. But if it's given and they give you value approximate, take the value approximate. Sometimes give 9.8, sometimes 10, take the given value. Not given, take the standard.
For calculation, we can take as a 10.
Again,
For calculation, we can take 9.81 as a 10.
no, 9.81 if given.
But we can take in calculation easy.
Easy
10.
if it's not given.
Got it.
Okay.
But if
Actually,
we-
here I can manage this one if like this the choices is clear here. But sometimes the choices is close together.
Yeah, point in point.
But for example, here it is clear. Okay, you can consider as a 10. I can solve it
10.
directly.
Yeah.
We have here 10 to the power negative 6 and 1 0 2 0 and 3 it's 5 zeros and 0 is 6 zeros. All 6 zeros cancel with 10 to the power negative 6. The remaining is 25 divided by 10. It means the answer is
2.5.
2.5 direct without any calculation.
Yeah.
Go back to B and B node. What is the value for B and B node? B is the pressure is the pressure inside the piston. It means referred to 50 kilopascal. Okay, and B node is referred to the pressure outside. It means they refer to outside pressure, atmospheric pressure, which is 1 atmospheric, 1 bar, 100 kilopascal. Okay, but when you're going to substitute, if you substitute for B 50 kilopascal, and you substitute for B node for example, is 100 is wrong. Why? Because you use two parameters different. Why? Because the first one for B, he mentioned in the question, this P is measured above atmospheric. It means it is gauge pressure, not absolute. But for B node value, as you know, for 100 kilopascal or 1 bar or 1 atmospheric, this absolute pressure. So should be these two pressure measured from the same data. Use both as a gauge or use both as atmospheric. As absolute. Use both as a gauge and or use both as absolute.
Absolutely.
If use both as a gauge, it means the first one is 50 because it is already gauge. But the second one, B node, the gauge for atmospheric is 0 because this is the data for the starting gauge measure. Here is 0. So I put 0. But if you use both as absolute, so in this case, the first pressure will be 150 kilopascal, not 50. Why? Because this 50 kilopascal and the added 100.
100.
The distance between these two to change from gauge to absolute.
Absolute.
And in this case, I put the other one atmospheric as absolute.
50.
Normal, 100.
100, sorry.
So the difference is what?
50.
Same like this.
Same. If we do like this also, we are getting the 50. If we
Yeah,
do-
but the wrong side, if you use 50 with 100, is totally wrong.
Yes.
Clear?
Yes.
Okay. Any question?
No, sir.
Buoyancy force. Actually, buoyancy force, this other topic here, not topic, other lesson. For buoyancy force is a vector upward all the time. Upward all the time. What is this also? What is this force related to what? Actually, this force is coming is from the weight of the mass of the surrounding fluid that would fill the emerged body. You have another definition, but easy. Yes, weight of displacement fluid. Weight of displacement fluid coming from where? It's coming from the body immerged inside liquid or floating, whatever, think floating, whatever. Okay, but we have body, we put it in the fluid. Whatever, totally submerged, floating, no problem. What happened for the liquid? Going up, raised. Is this the weight of displacement of fluid? This is due to buoyancy force. Due to what? Buoyancy force. Okay. So the equation for buoyancy force as you see here, FB is equal to here. FB equal to rho GV. Rho is the rho for density of the fluid. Density for the fluid. G is gravity and V is the volume of the body. But this have question, have note. What's the note? This volume, it is not the total volume of the body all the time. What's the meaning of the time? If this body is totally submerged, it is the total volume for the body. But if this body is floating, this volume, it is only the part submerged, but other part not including in the volume. Clear this?
The floating part.
Yes. No, the floating part, yes. The other part outside, not measured. Only this part is going to calculate it with volume, this not. One, according to this phenomena here, this property, we can use one device, it's called the hydrometer. This is used to measure the specific gravity of the fluid. The specific gravity, which is gamma, it means you can measure the density. It means one of the devices used to measure density or specific gravity. Specific gravity is S. Specific gravity, measure a specific gravity, or if you measure this one, it means you can measure this, or you can know this. It's the same. So a hydrometer is a device. It is used to measure this specific gravity or to know the density or specific weight according to the function of buoyancy force. So buoyancy force normally it is used for balancing and stability of the bodies. Okay, let's see how to measure the stability of the bodies by next slide. First, solve this question first. Answer is
B.
B.
Less than.
Sink down. 3.4 is less than weight. Okay, this question and one photo. I will just bring this photo to imagine what I need to discuss with you. But actually, the question itself is this not related to the question, but after you understand this figure, you can solve the question. What is this? Actually, this ship, as you know, the ship by default, when it's moving, is rotate right and rotate left, correct? Okay. During this movement,
just previous question, please.
okay.
Okay.
For this question, or this figure first, we have a body. This body shape, it is rotated left and right during moving, but we need to aware this shape is designed correct or not. It means it will be sink or all the time will be floating, not sink. This according to buoyancy force. How to know that? Actually, for a simple bodies, to make a balance for this body, the body, it is under two forces. Weight is going down, buoyancy force going up. And the body, it is stable with two forces. Okay. Normally for any body, or any force first, any force, it is acting on buoyant. And we have line of action for this force. Line of action for this force. So if the shape is similar, for example, similar square, by default, the point for the acting force, it is the point of intersection for two diagonals, for example. Here for this body, we have G, and this G is all the time referred to center of gravity, which is referred to the weight line of action. It means where is the weight line of action? Like this. Start from this point and going down. Clear till now? Okay. Means the body weight is going down all the time and from center of gravity. And center of gravity or weight is depend on the total shape. Total shape. Again, total shape. But another side for buoyancy force. Other force to make this body under stability, under equilibrium. This force is buoyancy, is acting on a point is called C. Is a point of buoyancy force and going up. As you see, the two line of action of the forces on the same line. This body is stable. This body is stable. And the force of buoyancy, the center of buoyancy, this is the point of action, same like center of gravity. This point can determine according to the shape of also of the body. But which shape? Only the part submerged inside here. It means
the part is inside the water.
This part inside the water body. Not total body. Clear?
Yes.
Check the other shape for this one. If this one is rotated like this, what happened? G is still the same, not a change, because it depends on what? Total shape. But center of buoyancy
is not
shifted and still acting up, no problem, because all the time is acting up. But shifted according to the part now inside the water. So we have two forces like this. One up and one down, and we have in between what? Distance. What create now? Two forces equivalent have distance between these two forces. What happened? Moment. What happened? Moment. Two forces equivalent and they have distance, moment direct. What's moment? Rotation. This is up and down and they're going to rotate in this direction. Correct or not?
Yes.
So
option.
So what happened? Rotation, moment, create moment. And this direction, according to the balance for these two forces, the moment in this direction. It means this ship should be going in this direction. Correct? It means this one is stable because it is rotated right, but the moment created going in opposite direction left, it means in a stable direction. And if you extend the line for line of action of G and C, we will get the point M. Point M. M is meta center. Meta center. This meta center, if it is above this intersection, if it is above G and C like this, it means the rotation and the moment created all the time, it is in opposite direction for the rotation. It means going balance, going stable, to be stable. But if this M below, when below, in another shape, if we describe this one and just mention for this C in other side here and below, we will found the rotation in the same direction for the rotation of the ship. It means this ship not stable and we will be sink. And this GM also, another thing, GM, distance from center of gravity to the point M, when we increase this distance intersection increase, this is going to be more stable for the body, more stable for the body. And this distance, when you're going to be decrease, this less stability. Clear for all engineer? Okay, according to this figure and discussion for this figure, kindly solve the question here. Solve the question, please.
Okay.
Which answer? Okay, you can write answer here on chat. Which answer? C, B. Okay. Okay. Actually, the answer is, according to the question here, 1 meter and 1.5 meter, body A and body B. I tell you, when this meta center height between G and M is increased, we're going to obtain more stable. It means the body B is more stable body A. Thank you. Answer, please. Okay. Yeah. Answer is A. Okay, any question for this part? Any question for this part? Okay, thank you. Now we are going to first exam.